Thank you very much for doing this, for being with me today. You're the first ghost.
Thank you for organizing this.
Yeah, I'm super excited to do that because I already have like several interviews scheduled and very interesting subjects as well. And also it's a good opportunity to see all of my friends from the sector of energy and ecology. So thank you very much and welcome. So I think it would be really nice if we start with like a brief introduction, what are you doing, and then we slightly go to the introduction of our topic today. What do you think about it?
Well, of course, the brief introduction of myself. Well, I'm an electronics engineer. I worked as an electronics engineer for some time, and then switched to machine learning because it's also a hot topic and a bit hyped out. Wrote a master's thesis about it. Was a course assistant in teaching students about machine learning. Actually, that course won the first place, but yep.
First place in Finland, in Finnish university.
In our university, it was like top 3 courses in the university. Nice. And well, right after my master's thesis was submitted, I felt encouraged enough to go and actually serve in the Finnish mandatory conscription army. And I am back just 2 weeks ago, but for the most time, I was not out of the technological loop because I was programming and doing stuff.
Welcome back. Welcome back to the free life. How was the army? How was the army and how long did it take?
It was actually excellent. It was just 9 months, from 6 to 1 year. I was like just in the middle. Well, maybe 1.5 months were actually professional soldier preparation, and after that I was taken as a more scientific and research person because of my set of skills. And I'm really grateful to Finnish Army because I was able to make a research on the free topic, and I chose it so it could be published later. So almost everything I can just tell and describe and discuss.
It's perfect. Yeah. Thank you. Thank you for the brief intro. It's very, I think, interesting. And I think what is more interesting is that like all of this machine learning, artificial intelligence topic are very hot topics, as you mentioned, but only few people really understand it, because I was also now I started to write my thesis, and it's part of my thesis is energy consumption prediction using machine learning. And when it comes to coding, it's very, very difficult, and I'm not like, I think 99% I don't really understand what I'm doing. So that's why it's very great now to talk to you about all of these topics, because it's your job basically. So
well, of course I have been teaching some people, and in case you have some questions like technical ones, I'm really glad to answer. But I'm not sure that our viewers will be interested in like a lot of technical details, like the differences between linear activation functions, or how the convolutional kernels works, or why ResNet is better than just a standard CNN, deep CNN. But instead, what could be more interesting is that I've noticed that we have now this machine learning, which has appeared maybe 10 years ago, and it has become quite massive in around 2016, 2018. And at the same time, we have several emerging technologies. And I can see that if they are combined with machine learning, it leads to very interesting results. It's quite transformational for our society, and it also has some effect on ecology. So I have 3 topics to speak of. The first is augmented reality glasses, how they would change things, then self-driving cars, and then extremely aspiring topic, the waste sorting robots. Wow. So which one would you like to
so now I have to do the first. So you think we will cover all of them? Then it would be great. So I think since I would actually choose the third one as the first one, because because it's maybe my personal preference. It's one, I think it's very interesting. I'm super excited to hear the details. So I think let's start with the third one, with the how did you say it, like waste management with machine learning or something?
Yeah, basically, this is an excellent choice, because then we are going to go in the chronological order, because this technology actually exists already right now. So these are the special robots, like imagine yourself in a conveyor, and there is different waste that needs to be sorted in different bins before further recycling steps. And previously, this stuff this has been done by humans. They were just standing there smelling all the stuff. Sometimes they were needles, sometimes they were knives. It was not a very well paid job. And currently we are basically using neural networks and building sort of, well, they look like a 3D printer, Delta, or just robotic arm, depends on the construction and on particular startup. And they take the piece of waste and put it in the bin, and they do this really, really fast, much faster than human. And this is, for instance, an excellent illustration of how the standard convolutional neural networks can be used, because this is a perfect image classification task. And here we have some advantages compared to humans, because, well, robots don't feel smell, they don't get injured that much as humans. They can observe this waste in different spectrums and get some additional information before they decide like where to put it, and they're just simply faster. So, but of course, the most important is that first it is helpful for our environment, because it decreases the price of sorting things out. And second, a large humanitarian aspect, because these jobs, they are not the best. It's very, well, quite uncomfortable working conditions, not very safe, and it's just detrimental to human dignity to stay all day and sort out someone's waste. And if you can imagine, if there is like a COVID mask, there is a chance to get COVID and stuff like this.
I have a few questions about it, if I can ask at this point. What do you think is the like accuracy in percentage for such robots? Like, what is the risk that they will confuse some sort of waste with another one? And because you mentioned that it's image classification task, and I think just recently I saw how machine learning fails. I think maybe you also saw it, like when they had like an apple or like a bag, plastic bag or something, and they put like a logo of Apple there, and the machine thought it's just an apple, but it was like no, I don't remember. So I think the machine was just confused about this logo.
Oh yeah, it was one of the latest transformers architectures, and what it does, it can read the text from the image, and well, it was classifying basically the text, not the item itself. On the one side, it's an example how, well, dumb neural networks are, how they do not have the sense of general context. On the other side, it's extremely bright example of how they are able to actually read the text from the image without being specifically trained to read the text. So that was quite a fascinating one. But yeah, that's the great question. Actually, what I've been reading about these robots is that the accuracy is really high.
Yeah, and maybe I just forgot to ask another question in the very beginning, in case somebody don't understand what are neural networks or how does machine learning works. Maybe can you please briefly explain it for like general public, or maybe some people heard it, but they don't really know what is actually the thing.
I'll try. Well, let's say in the conventional programming that we had before 2010 or something, what we did, we had some rules that we put into computers, and computers then process the data according to these rules. So now what we are trying to do, we are placing the data into the neural network, and we are showing the result. And it tries to figure out what are the rules. So the rules are the output. But in principle, the current generation of neural networks, they are mostly pattern matching machines. maybe that's a common story right now, that convolutional neural networks, like the first layer recognizes some small features, really small, like angles and some maybe lines and of different inclination. The next levels, they recognize like simple structures. The next level, they get higher and recognize like an eye and ear or some other parts. And essentially on the last layer, we have to get the classification, like, is it a cat or is it a dog? So what we are doing, we are feeding like a ton of data. So if anyone wants to start machine learning project, that will be perhaps a main requirement. If you can collect like 50,000 images, then it will probably work. And then we just feed it inside this architecture that kind of slides the pattern matching windows on the image, and tries to adjust this pattern matching image so it like forgets the irrelevant information, filters it out, and leaves only the relevant ones. And along the neural network, like the information about individual pixels get lost, and more high-level information about like features, about like what the thing generally is, it kind of gets filtered out, and in the end we get a classification. Of course, this is not the whole story. There are like recurrent neural networks, there are like transformers and all kinds of architectures, but we probably do not go too deep into details.
Yeah, I think it was a good explanation, and also maybe with our discussion it will be more clear with examples. So, but do you have something else to say about waste management robots?
Well, if I finish about the neural networks, one important thing that to realize, to understand, is that current generation of neural networks, they are learned only once in the laboratory, then they are kind of frozen, and then when they go to the production environment, they do not kind of modify themselves to fit better to this or this task. So it's not like we have a strange magic demon or some small gnome that sits inside the computer. We like more like we have this very fine-tuned filter that is frozen, and it just works with some sort of accuracy.
It's a good example of gnome. I like it. But coming back to robots, or you want to still talk about in more general about neural networks and machine learning?
Probably I would not take too much time from our viewers, because there are like tons of materials how to what are the neural networks right now and how to use them, because we have been pushing quite hard to lower the entry barrier. So now essentially any guy with software skills can use some ready-made libraries.
A guy or a girl?
Of course.
Because actually yeah, tell me.
Yeah, I actually love Finnish language because it has this non-gender pronounces, hen, and yeah.
So, and what does it mean, hen?
It's guy or a girl.
Ah, so it's both.
Yeah, it's just, conscious entity.
Somebody.
Yeah.
Someone. Yeah. Okay.
Yeah. So when we are returning to this waste management, it also means that we need to have less people in the management facility. So that means that people do not need to travel from home to work and back. And this also decreases the carbon emissions. Of course, there are some negative sides, because there are some technical guys who have to maintain the robots and make sure that they work properly, and reinstall them, and replace the neural networks time to time when they are getting upgraded. But in principle, this decreases this travel quite a lot. And that actually gets us to the next topic of decreasing the travel. So this gets us to the topic of self-driving cars. And I believe that they would change our society quite a lot, because current trends in the cars, well, there have been trends at least since 2012, but still. They are self-driving and they are electric. And starting with electric, that means that a person who owns an electric car would be able to put it in the garage and use it as a part of the energy grid. So it is like a balancing element.
It's a flexibility, right? It provides flexibility
and redundancy. So in the times, for instance, when the wind is blowing quite well and the sun is shining, these cars, they can gather some energy, and in the times when there are big consumptions, they can like decrease and sell this energy to certain amounts. And this actually
and it helps to balance the grid eventually.
Exactly. So it has exactly the same role as the forest in ecosystem. So it accumulates the water and then leaves it back in the form of small springs and
very good,
rivers.
very good, like connection, or how can I say? I didn't think of it. It reminds me of the forest as well now. Yeah. But the issue. Oh no! Tell me. Sorry. Yeah.
Yeah. Sorry. And one more thing is that it actually opens a completely different type of economy. So, for instance, I have heard from my colleagues that there are quite money efficient and profitable projects about building the pretty much huge battery warehouses, and then writing the software for this battery warehouse, which automatically decides when to buy energy and when to sell it. Also based on machine learning and everything.
Yes, and it machine operates in the energy selling market automatically. It's like a stock market, let's say, right?
Exactly. And this actually creates a completely new type of economy, because it's not like the human who makes the decision when to pay money, it's the machine, and it's pretty huge money. And it actually reminds, exactly like you said, this stock market where thousands of robots, they trade with each other and try to like speculate. This is like in principle unpredictable system, because the moment some robot is able to predict it, like it interferes, takes some piece of money and makes it unpredictable once again. Like in the quantum mechanics, the measurement changes the state of the system. But why does it work? Why it doesn't just fall apart? Well, because they are in general solving their minimum energy. They're trying to minimize the energy of the system. So they're trying to balance the supply and demand. So that's why this altogether kind of works. But yeah, I maybe diverged from the original topic of our discussion, and maybe some question about this one.
It's okay. We have time. It's just it's a very interesting. So now we are in the topic of self-driving cars and EV vehicles. But I wanted to comment a couple of things about it. I guess that it means again losing jobs, and because drivers will not be needed anymore, and it again requires, I guess, very much like requalification of the staff, because in this case they will have to, for example, past drivers will have to be, for example, technicians for such warehouses which are connected to the EV vehicle chargers, or they'll have to be like their new job will be like a staff assistants, technicians for the technical assistants for the EV vehicles. And the last thing that I wanted to comment on is I just wanted to say that like energy sector is transferring to a completely different new entity. But luckily we have some examples from different sectors to learn from, as for example already mentioned stock market, let's say, because like trading with energy nowadays reminds of just trading with like some like everything else. So and then it brings us to so when you were talking about machine learning related to self-driving cars, you mentioned two things, right? You mentioned this automatic trading because of the automatic trading with energy that we store from electrical vehicles is the first thing, where we can use neural networks. And the second thing is that self-driving car itself, right? When it makes decision according to the algorithms. Am I correct? Was it your initial idea?
Oh yes, exactly. And there are of course quite a lot more, because thinking about self-driving cars, battery is only one part of it. Because it needs to be self-driving, we have to put quite a decent hardware inside of it. For instance, think about current insufficient supply of GPUs. And people are going to some extreme lengths to obtain the newest generation of graphic cards, because everyone wants to get quite good performance. And these self-driving cars, they have to have pretty good hardware, which changes the role of the car quite a lot. Imagine that inside your garage you have the whole server part in. What they could also be doing, they could be an element that supports our whole financial system. I guess you heard about cryptocurrencies and that they require quite a lot of energy and computational power to operate, at least sometimes some types of them, quite traditional ones. And that could be also leveraged to the car. So they could be the essential part of our energy balancing system, and they could be an essential part of our financial system. And this is just from some originally vehicle to travel from point A to point B.
Yes, I'm listening. I'm just documenting stuff.
Yeah. And of course, I guess we will also be running all kind of computationally expensive tasks on these cars, like playing games, training neural networks, doing some research with lots of numbers and lots of computations. Well, don't know about that. But one more thing that comes out of this is that these cars, all in all, they could be quite a good workplace. So imagine yourself that in the morning you wake up, dress yourself, get in the car, then drive to some nice forest or park or some scenery location, and then just hang up and take a look either at the screens, or maybe you have like virtual reality glasses, and you just relax and work in a very comfortable position, completely not in the office, without the risk of conducting infection, without the need to stay in the traffic jams, and doing some creative work, engineering, research things.
That would be perfect for COVID, for situation like pandemic, right? As you mentioned.
Yeah, essentially a personal office, and no one is interrupting you because you have your own personal space. But right, and related to the cars, there is this joke that currently our holy grail is the autopilot level 5. And George Hotz, the head of Comma AI, which is one of the main companies that develop autopilot, he estimates this to be maybe around 2028. But of course, we can go further to autopilot level 6. So this is when the car actually not only drives you without your explicit interference, but it actually decides where you need to go without your explicit input.
Ah, wow. And do you know technically how it works? Like how? Like maybe I can assume that it may be according to the past historical data that the car has, where you usually go at, for example, it's 5 a.m. or 5 p.m. and you usually go, I don't know, shopping, and then brings you shopping. I don't know, this is my idea how it can work, but what do you think? What is like technical background behind?
Well, technically, I would say that already level 5 would probably require something very close to general artificial intelligence. So neural networks that can replace humans, which are not on the plate right now, but well, can happen in any time in the next 20 years with increasing probability.
You are
And
a
this level,
visionary. You're one of these visionaries.
yeah, well, maybe, maybe all the time saying it's not about this is not so well grounded in reality, but you know.
But Ruslan, now at this point, because the proposed topic was machine learning and ecology, so I would just like to stay a bit more, and maybe now, like just brainstorm about. We can talk about glasses later, as we will maybe leave this topic. We will leave this topic to the end, like as one of your planned topics to talk about. But maybe now it would be interesting to just brainstorm how machine learning can help to reduce CO2 or to reduce other pollutions from the air or reduce ice melting on the north or all of these climate issues that we can appear. And for example, if we are talking about in case of Russia, it's like, I guess if you look at the 2 years later, in this perspective of 2 years, I think a lot of ecological disasters happened in terms of ecology, such as, for example, in my region, in Krasnoyarsk Krai, it's in the heart of Siberia, and there were super big floatings, like when the river came out and in several villages were flooded. Then, for example, a forest fire, big forest fires, which were huge. I think it was 2 summers ago. I think you probably heard about it, and which you could see that from the space, you could see the smoke from these fires, and and I think, and I guess it's not that hard to just correlate climate change with the topics, with the disasters like this. So what do you think, for example, like I just wanted to tell what I was thinking before, like related to forest fires, and I guess this is how they manage forest fires in Canada, is that they are connected to basically satellites, and when satellites detects smoke in certain location in the forest, it automatically sends the signal to the closest fire station, and then they can just localize, extinguish it immediately. So if we just think in this direction, do you have something to comment on this, maybe?
Yeah, perhaps. One thing to notice is that neural networks, they are acting fairly well in the domain distribution, but they often act quite poorly out of the domain distribution. So that what that means, that if you, for instance, train it on the past data, they will work and they will produce reasonable predictions based on the situations they have already seen. But if the situation shifts from this local equilibrium and it shifts dramatically, then these models they stop to work, at least the simple ones. So what is possible to do is possible to make quite comprehensive models of current situations, of fires, of firefighters who are reacting to them, of local populations, of available aviation and stuff like this, and then create hypothetical scenarios, which would then train neural networks on the scenarios that even original people who would code this simulation could not maybe even predict. But that's quite, as a person who has coded some of these simulations, it's quite complicated, and well, the sooner we start, the better.
But when you mention about domain, that neural networks work well in domain distribution, you meant that we have to identify, by domain you mean that we have to identify some borders, or what do you
Well,
mean
imagine
exactly?
yourself like a neural network that has been trained on Emmys to just numbers, or for instance to recognize just dogs and just cats, and then you show it an image of the bread, and you cannot ask you are asking it, okay, what is this? Then it tells you, okay, this is the cat with this probability and this is the dog with this probability, because I was never trained to recognize bread, or I was never trained to recognize, I don't know, a lion. And these are examples of out of domain
Right,
things
right.
that it cannot handle. And there were some examples. So when for instance, the financial crisis happened, the models that were designed to work in the, let's say, standard circumstances, they were showing like crazy things, because just the situation came out of this equilibrium. So yeah, that's this fundamental problem of how
to define the
networks.
problem, basically, right? It's crucial to define all possible ways that can happen, I guess, in the very beginning.
Yeah, and when we are trying to make the simulation that complex to train neural network on it, it becomes also very like hard to develop. So
okay,
that's the question, when our neural networks will be smart enough to replace humans, but then we will have another set of problems. And as I said, well, we don't know when exactly this would happen. Our best estimates is about like 20 years.
But when we are thinking about specific ecological disasters, like as I mentioned, forest fires or floating or pollution or like deforestation in general, or like land, how do you call it when the land is not capable of I don't know how to say it in English, like when we cannot raise things on the land anymore. It's also due to different problems, or also
well,
lack of water.
I came from army, so I guess we can invent the term deserting. It turns into the desert.
Yeah, deserting. Okay, let's call it like this. But let's maybe just brainstorm, like how can we, I don't know, for example, there is a river which is going out of its usual borders, and we want to stop it or predict it at least. I guess it's also all possible to integrate the machine learning with that. For example, we can put some, as you mentioned, the sooner we start, the better. The more data we collect, the better. Maybe like we can measure the water level. I think for an engineer, it's pretty trivial how to do it theoretically, but I guess in only few places on Earth it works like this, because otherwise we wouldn't be hearing that much that almost each month there is somewhere there is a new ecological disaster somewhere in the world. I guess if we use machine learning more and we collect data and predict more, if it would be more popular, then maybe we would avoid some problems in our land.
Yeah, I understand what you're talking about. Well, essentially, I would say that there are two problems. The first is predicting, and the second is reacting. And in the space of reacting, the humans are probably the best, because they can think outside the box. They can make decisions just in the situation. And in the sphere of predicting, yeah, I guess it is quite possible, because we can technically collect a ton of data, taken images from satellites, take like all kinds of maps, like
sensors,
humidity, temperature, others, place like a ton of weather stations, and try to, if for instance some things that we would classify as disastrous, for instance, the combination of several conditions which leads to huge rains, which leads to a flood, will happen in the place where we know that people are living, then we can at least tell them that okay, that will probably happen. Or if the situation seems similar, for instance, we know that this area is flooded somewhere else, like once in 100 years, once in 50 years, and some people like build houses there, and we can tell them that, well, maybe not,
it's
that's
risky.
not the best idea.
Mm-hmm.
Yeah. That kind of preventative measures that could be quite useful.
I agree with you. It's a good approach. But then when we are talking about this, and I think it's not that hard to do, Do you think, what do you think, like how much it would cost, for example, to, I mean, it's a very rough estimate, of course, it depends on the country or the technology that you use, but do you think, like in a context of, I don't know, middle-sized country, as, I don't know, let's take, for example, which is middle-sized country, I don't know, like,
Well,
a lot of them, like let's say Morocco is like not that small, not that big, so in I guess, or Egypt, so in, like, for example, Egypt, I think one of their huge problem right now is that they're afraid that Nile will have no water anymore, and because of the power plant, which is hydro power plant, which is built somewhere in another country close to them. So do you think it's do you think it's a big, like, huge project to implement, to put some sensors to collect data, or even we don't need maybe sensors because, as you said, the weather stations can give us access, or but is it difficult to write all of these programs and try to predict some disasters? I don't know, what do you think? Or like, because we already know that there are forests, there is tundra there, Amazon forest there is Canada, Russia. I mean, we talk about fires, then we at least know where it can potentially happen, so maybe we can try to prevent it. And it's my first question. My second question is, who is in the end, is it only the government of the country, of the particular country, responsible for that, or is it the whole world, you know? So I don't really know. It's very...
Yeah, you're raising a very important question, because when we will start to develop the technologies to control weather, to give, like, let's say, more rain over Israeli, the canonical example, then, well, maybe some neighbor countries would react and say, hey, this rain could also could have been dropped, like, over our territory and increase the fertility of our land. And there are quite a lot of contradictions between the nations. But returning to this example that they are fearing about the Nile getting out of water, well, that's one of examples that neural networks are quite problematic to work with, because ideally what we need we need like 25,000 of pictures of cats and 25,000 pictures of dogs. And we have this situation when we have this dam just once. So it's not very, we don't really have the data to train neural networks on this. So it lies in the domain of few shots or even one-shot learning, which is currently under heavy development, but it already, like, goes into this side of general artificial intelligence.
But I guess sorry, just one comment on that. I guess like if we are talking about floodings, it's not on, or like forest fires, or like land devastation. We can just have data from other part of the world and just accumulate it with the data from, like, with the local data. So that might be not a big problem.
I would say it's definitely possible, and I would even, I'm not sure about the exact state of the situation, but I would guess that the Egyptian government has already run this, at least on the level of expert analysis. And
I was also thinking that in the 21st century, forest fires is not a big deal, but apparently it's not. And floodings, it's like, it used to be in 5th century, and now it's 21st, and it's still not manageable that well, you know? That's why I'm surprised. Then this,
of course, the part of the problem is that forest fires are the part of the forest normal life cycle, because there is a canonical example of how in Australia they stopped cutting down trees, and then they eventually got a devastating forest fires, because there was no forest fire for such a long time that extremely flammable trees grew.
To a certain extent, yes. To a certain extent, I agree. But to an extent of like a forest fires, which is almost as big as, I don't know, France, then it's, I think it's a problem, really.
Of course. Well, if we are going to take an upper hand of the situation. We can, for instance, build a swarm of drones and just spray water over the territories.
Can be. So I guess we can finish with the topics of disasters. It's not that nice to talk about, unfortunately. And we can come back to the third topic that you mentioned, which are VR glasses, and then maybe we can make some conclusions how to use them with the topics of ecology.
Of course. Well, this is one of the last potential topics that I have some solid ideas about, and one of the last technologies that is emerging on our eyes and will definitely make its way to our lives. And this is not only the VR glasses, but AR glasses, so augmented reality. And in my opinion, there is a pretty huge difference, because with the VR, we are pretty much connected, bound to a certain area which is safe to walk in. For instance, we need to have the room in our apartment, preferably without any obstacles or cats that we can accidentally stump upon, and then we can just act within this very limited environment. But with AR glasses, we can just walk around and do all the things like read text, read some additional virtual interface suggestions.
Of course, yeah. It's like mixed
get
with
a lot of
reality and some virtual parts.
Yeah.
Okay, I get it. Yeah.
Yeah, and I think like one of the concepts which could be quite awesome is that imagine that you're going to shop, for instance, for new clothes, and then you automatically get some ratings about, for instance, how much resources has been spent to produce this or that piece of clothes.
Yes.
And you automatically get some information how easy it is to recycle it. And then you base your choice also on these two parameters. And it's also possible to involve like more people into it, like automatically, like maybe even some elements of gamification. So automatically give some discounts or like raise some reputation for people who intentionally change their choice to more environmentally friendly options. Of course, this is a bit hard topic, how to certify which thing is easy to repair and which thing is hard to repair. But
maybe, I'm sorry, maybe just if you look, because each new piece of clothes has this label where you have like, I don't know, 80% of made of wood and then 20 of polyester. And then if you scan it with the glasses, then maybe the system can, you know, more or less calculate the weight of the thing, and then like what it's made of and how easy it is to produce it. And also usually I think it's an obligation, then it's the thing should specify where it was produced, and we combine it with the knowledge of where the person is, and then we calculate like the transportation, CO2 for transportation. For example, if it was produced in I don't know, let's take again Morocco, and the person that buys it in Russia, then we calculate all of the kilometers. So I guess it's very much possible and super interesting, actually.
Yeah, it also, I guess it depends quite a lot on which technology has been used, like how environmentally friendly was it. Because one thing is when we are making, for instance, some metal in the European power plant, which is highly certified in the middle of the city and has a very refined exhaustion. And another thing is when we are taking a look at some household metal production, which produces a horrible quality and creates a lot of carbon dioxide and pollution, and these things they have to be taken into account.
Illegal. Yeah, illegally metal production. Okay.
Well,
I never heard of it, but maybe it exists.
In principle, there should be some system of penalties if the technology which has been utilized has not been good enough, has not met certain criteria. And it's quite a lot of work and quite a lot of also work on the mindset level to convince other people to provide the solid information on which this like penalty or extra taxes could be calculated, because that's one of the problems with working with ecology. If, let's say, one country like Germany complies with all the regulations, but if it drives the price of the products a bit too high, then it loses a large chunk of the market, and then it suddenly gets out of the competition chain. So everyone should do this pretty much at the same time. So of course,
it's environmental, how do we call them, certificates that you receive. You buy one certificate. It's already working thing in Europe. The thing is that they're very, very cheap right now. There is like a market for CO2 certificates, and each industry has to buy it in order to produce a certain amount of pollution. And but it's pretty much the same price for them everywhere. So that might be the way to decrease the, as you mentioned, the differences in price. So yeah.
And also the system could be expanded to how much, for instance, fresh water it uses, the technology uses to produce this or that thing, or how much like raw material is wasted.
I remember one of your idea about the, I don't remember which problem did you solve, but like it was an idea to make artificial clouds.
Basically, an idea was to make artificial wind, because the problem with current windmills and that they do not work all the time. So the idea was that, okay, if we build like a really good weather model, and if we seed clouds in like the key points, then we can maybe like create the whole, we can force the whole system to like create the wind. And well, of course, it's a huge research topic, and
but it's not I liked it very much, because at first it seemed crazy, like how would you move the clouds, but then it's like, okay, why not? If they are there and it doesn't require a lot of energy, maybe we can, like, maybe it can be a solution. I don't know, to just simply
there is a lot of energy in the atmosphere. There is a lot of energy in ocean, and we're just not using it.
Yeah. Anyway, I think we forgot a bit about our viewers. I hope that somebody will view it in the end.
So I hope it was quite a good mixture.
It was great. I want to thank you very, very much for being on this interesting journey with me, because I'm just starting, and I hope in some days after I will interview a lot of people, then you can come back with a new topic, and just feel free to always reach me and propose something. And I thank you a lot again very much. It was very nice to talk to you.
Yeah, thank you. Well, like and subscribe.
Like and subscribe.
It's a bit strange to be on the other side of the screen.